So this panel is actually about a person who has been instrumental and very important for the lives of so many simulation and operational research and many other people in information system and higher education in the UK, who passed away last year exactly on the 29th of March. So today, coincidentally, it wasn't planned, but he is always like this, always tricky in his life and his death. So today is the first anniversary of the passing of Professor Ray Paul, and this is a memorial panel. We're not going to talk much about the personal aspect. I'm sure they will come, but it's mainly about his work in simulation. He is the first professor of simulation in the UK, and I'd like to just keep you engaged about some interesting work that he has done throughout his career. And I have the panel with me, Professor Stuart Robinson, Professor Simon Taylor, Professor Sarah Brayford, Professor Navneel Mustafi, and we will talk in turns about his work. But before we go, there was an interview with him in December 2013 by Dick Nance, who is one of the pillars of simulation in the US. And this interview, it's actually a 55 minutes long interview. You're not going to be here for it. Also, I put a link at the end of the presentation, and you can search it. I think, Ray J. Paul, David, I will show the link later. But the first 5 minutes is enough to give you an idea about the importance of the person and also his personal approach to life. So let's watch it together and then we'll go.
Dr. Paul is a retired academic from the UK. My name is Richard Nance. Dr. Ray Paul has contributed in breadth and depth to discrete event simulation technology. In part, the breadth of his impact on simulation stems from his research in information systems and the interplay between computer simulation and information systems, and also the extent of his applications, ranging from manufacturing to healthcare. His early research focused on manufacturing applications that serve to stimulate his questioning of the modeling environment needed to support the modeler. In particular, he investigated artificial intelligence techniques, specifically expert systems, as a supporting tool in the modeling challenge. His work with David Ballmer and George Dukaitis led to the establishment of the Center for Applied Simulation Modeling, or CASM, at the London School for Economics and Political Science, that drew international recognition. CASM was moved to Brunel University in 1992 when Dr. Paul accepted a position there. Dr. Paul is also widely recognized for his research in information systems. He co-founded the European Journal of Information Systems and chaired the editorial board from 1991 until 1999. He was instrumental in the establishment of the Journal of Simulation in 2006, and more recently, in 2012, the Journal of Health Systems. Additionally, he has served on at least 6 other editorial boards. While amassing a distinguished record in scholarly contributions, 3 books, more than 250 papers, and some 55 PhD students, 35 in simulation. Dr. Paul is unique among simulation pioneers, I think, for his lengthy and impressive record in academic administration. His service to Brunel as a department head and dean of 2 faculties and a 3rd on an interim status is truly remarkable. Known throughout the international simulation community for his witty, insightful, and often provocative writings and addresses, Dr. Paul is widely sought as a speaker and commentator. He was awarded the ACM Special Interest Group on Simulation Distinguished Contributions Award in 2008 and was named a Companion of Operational Research by the Operational Research Society of the UK in 2009. Dr. Paul, may I call you Ray?
Please do.
What led you to simulation as a topic of study or interest?
I must say it wasn't something I was conscious of doing at the time. I set out to do a PhD in production scheduling, involved with simulation model itself, where I learned some of the dangers. I still wasn't that enthusiastic about doing the research topic because I couldn't see there's anything new to do. It seemed to me at the time that everything about simulation was logical and sensible, and therefore all you have to do was apply it. And sometime later, I discovered it wasn't quite like that. When I worked in some consulting for the Ministry of Defence, although it was logical and sensible, it didn't work. That's why I thought it might be interesting to research into the subject area itself. Why didn't simulation work as well as it should in the Western Isles possible? That's the reason I got involved in simulation research.
So, throughout the life cycle of simulation, Ray has proposed so many ideas and instigated so many visionary thoughts, and we will talk in turn about them. And
Dr. Paul.
oh, sorry. There are also going to be overall reflection on his work and the current situation and what's going to happen in the future, hopefully. So we start with Stuart Robinson.
Very much to that. Yes, well, you've used the automatic spelling there. That's what happens to my name when it's all right. It's a regular occurrence I have in life, but no problem. So I'm going to actually start and be completely ignore everything that Talal said and give you some personal reflections because I just felt it would put a bit of context and actually important for understanding a bit of Ray's impact on the UK and the international simulation field. And my first interaction with Ray was actually 1992 at a winter simulation conference in Washington, DC. And I'm going to call it the point at which the Brits invaded America. Sorry to any Americans here. But there was just, well, I'm going to say there were just three of us, myself, Mike Pidd and Ray Paul at winter simulation that year. I think probably Russell Cheng was there. Didn't bump into him. Perhaps he was avoiding me. And I think Russell had been previously, but for the three of us, that was the first time we've been at WSC and we were pretty much the only British people there. And that was actually when I first met Ray and got to know him. And in fact, for about 5 years, I only ever met Ray in America, which is ridiculous because he lived about 100 miles from me in the UK. I stayed in touch with Ray, and after a while, I made the mistake of asking him, what's this simulation study group that you run? To which he said, well, I don't really do anything anymore, but you'd be great. And I know somebody who could help you called Simon Taylor. So he introduced me and Simon in 1995, and we took on the simulation study group, which is now known as the Simulation Special Interest Group for the OR Society. Ray also examined my PhD very kindly, I have to say. So he was my external examiner back in 1997. And then as a result of the work that I've been doing with Simon and Ray's encouragement, we launched the original simulation workshop back in 2002. So I have to say we would not be here today if it wasn't for Ray's encouragement and heavy prodding to set these sorts of things up. And similar heavy prodding led Simon and I to launch the Journal of Simulation. And one thing you'll realize if you knew Ray was you couldn't really say no. I did actually once get away with saying no, I have to say. He did on numerous occasions try to offer me a job. This culminated in about, I think it was 2008, WSC in Orlando, I happened to have my wife with me. Ray decided the best way to offer me a job was to take me and my wife out for lunch, realizing that I had to disappear to go and give a talk, to leave my wife on her own with Ray and a couple of others. And his tactic was to say, if Stuart comes to Brunel, we'll pay him loads of money and you're near the shops, so you can go shopping a lot. It didn't work, okay, as you'll realize. Anyway, so what was, and I think those are important because Ray made significant contribution, not just intellectually to the field, but to the development of the field. So some areas Ray worked in, just some very quick things. I'm going to concentrate on 3 areas particularly, but we will, and I think Simon, you're covering this. He, and you saw it in the video already, was really at the forefront of thinking about AI with simulation. And I'm going back to the 1980s here. So everybody's very excited about AI these days. There's the paper, 1991. But actually, Ray was working in that well before any time. It was really a major field. Somebody talking about grab and glue? Yeah, okay, so we'll come to that in a bit, but these were again an area of vision. He had concerns about the idea of model reuse. I think we still do. And the primary issue of, do you trust what you're reusing? And Ray worked in an idea of what he called grab and glue, which we'll come to. And he also worked quite a bit and raised ideas about the ideas of disposable modeling, fast and interactive. There should be an arrow there. There we go. Disposable modeling, which is fast and interactive use of a model to understand a problem, through to another extreme of modeling, what was referred to as software engineering, which we could use very much a kind of strict process when we know the problem and we can solve the problem. But Ray did some investigation talking to practitioners and saying, which do you use? Sort of disposable rapid modeling or software engineering? They both said, well, anybody he spoke to said neither. And what he identified in the middle was what he referred to as investigative modeling, which is about looking at problems that aren't fully known and problems that fully keep changing, and how we use simulation within that context. And just reflect on what we saw in the video about Ray saying simulation doesn't work in practice. And really what he was pointing to was, actually, if you try to work to either of these extremes, you're probably not going to succeed. We'd have to have a more adaptable middle road approach. But let me focus on 3 specific areas, if the slides, yes, they do work. Quite early on, actually, and the paper, I think, in 2001 was somewhat after the event, but Ray created a system called ClinSim, which was as it says there, outpatient clinic simulator. But the paper that we're referring to there very much focused on the application of this generic package. And the sort of insights that Ray got from it was, actually the package had no magic in its own right. In other words, it didn't solve the problem. So just having the simulation, putting data in it and it generating results didn't actually solve the problem. Of course, the results emerged and the benefits emerged from the participants that were using the model. And that basically the model was about helping to structure a debate and then helped participants to raise confidence in the outcomes from the model. And very much reflecting on the idea that actually simulations are, I suppose you'd say, decision support tools. They don't tell us what decision to make. They provide us with information to help us make the decisions. So the interaction of the human with the model is really important. And at that point, and this was very early days, of course, he was starting to look at the benefits, particularly of simulation using the World Wide Web, which was, of course, in early existence at that point. He did some work on visions of simulation and problem solving. Ooh, something's disappeared. I told you you'd edited my slides. I'll let you off. Anyway, don't worry. Interesting is that in this in one of his papers, who's disappeared off the scene. But here's the original kind of Law and Kelton law 10 steps to a simulation project. I'm really pleased he didn't use mine for this. He's basically written over here everything that's wrong with that sort of view of the world, that if you actually do modeling, that isn't the way it's going to happen. And what he was thinking about is, how do we teach people to do simulation in practice? And really what he was saying is, you know, when we're teaching students, and under this heading, simulation education is no substitute for intelligent thinking. I'll leave to Lau to tell you what the shortening version of that is. But basically, it was about teaching students. How do we teach students to use models to facilitate debates? How do we tell them and help them to know when to stop modeling, when they've done enough to get as far as they should? That usefulness is about solving problems, and we'll see in a moment, it's not about solving the models. And basically, you know, we often won't have great data, so we shouldn't be building models that are so heavily dependent on the accuracy of data. And what he was really saying is the way we should teach students is not a textbook approach, but throw them in there into real modeling problems. They might be slightly artificial real modeling problems, and say, work on this and see how you can work through the messiness of the real world. So really, just to pick up a sort of final piece of work he was doing here under the heading of, is problem solving or simulation model solving mission critical? What he was saying is that the mission of simulation is actually, of course, and we'd all agree with this, about problem solving, assisting understanding and helping people to change. And it is not about trying to solve the model. But of course, much of what we do, particularly in academia, is assume what we're trying to do is solve the model and not really think about the problem we're trying to solve. And he gives a lovely story here about a student of his who went into a factory. She'd only been there a few days. She was measuring, trying to time things. She measured the speed of the crane in the factory and told the engineers, your crane's not running as fast as you think. And they told her off and said, no, it's rubbish. Anyway, they went away and they did some more work and said, actually, you're right, the crane isn't running as fast as it should. So they speeded it up, and the work in progress problem went away, and that was the end of the project. Now, the point is, we would think of that as being a bit disappointing, but actually, of course, that simulation study that never resulted in a simulation was a tremendous success. So finally, a bit of literature. I know some colleagues here were involved with this, but he did have a real concern that we are focusing too much on solving the model, not the problem. And if you look at the literature, and I won't go through that in detail, but basically what he was saying is there's a significant problem that, you know, as academics, we focus on solving models, and there's very little evidence that what we do ever really or rarely solves a real problem. And particularly in statistics, there were no papers that they looked at in key journals that had any sense the solution was ever implemented. Talking of which, now.
Okay, so I'm going to speak. I'm actually going to shrink my slot even further because I feel that there'll be some repetition. But what I want to alert, especially the up and coming generation, that before there's something called something used to be called simulation environment. People were dreaming of a simulation environment because previously they were coding. Even though Tom is still coding Python, but leave that aside. So when we talk about environment, where you have the random number generator, or you have the visualization, and you have the output analyzer and all of that together. So the dream in the 60s and 70s, I wasn't there, but what they told us that in the 60s and also until the 80s, that we need to develop a simulation environment. So Ray was actually one of the pioneers for that, and he developed the CASB, which we mentioned earlier, the Center for Applied Simulation Modeling Environment, and that started by what we call, let me see, What did I do? What happened? Yeah. Here's the can't find it. Anyway, VS7, which is a Pascal code generator. So instead of coding directly, they use a VS7 interface where you can enter your model specifications, and then that will then translate it into a Pascal code. Then you can play with the code if you wish. I think I put earlier, Ray's dream was for modelers to model, not to code. And that the models and the simulation is to be at the desktop of the analytics rather than somewhere far and you don't have access to it. So that was what he was thinking about in the 80s. And what we're trying to see, where are we right now and what happened since then? And he had a graphical interface. It's called the Grace 01, which is also to support modeling. The Clean Sim is based on SimScript 2, which is an earlier simulation package, but it was a visual tool that is available for clinicians. And I think Sally will talk about this later. And then the final vision he had, which is software reuse approach for developing grab and glue. So the ultimate dream for him is that you don't need to do any coding, you don't need to do any development, you don't need to even buy a simulation software. What you need to do is to go online and you bring different bits and pieces from online and you put them together to create a model. And this could be entities, they could be queues, they're not necessarily based on one environment. They're just because your mission is to develop the model rather than and solve the problem, rather than trying to figure out how to code and all of that. And this model can be developed in a very pragmatic way. So what happened? Now, I think the dream about having a modeling environment, that's probably, we are here now. There's so many simulation tools and the simulation package is actually a simulation environment. So that is there. What we are not really close to, which is the connectivity between the different models and the different components to create a models. That still, we are very far. We have done a very small experiment about 12, 13 years ago by getting a clock from somewhere, a cube from somewhere, and an entity to try to put them and glue it together. And the problem was not really in the components. The problem was in the glue. The glue, and I think Tom was talking earlier about the Docker. That is what we term the glue. That is a problem. How do you bring different software, different pieces of software together and you put them? We don't care, we are modelers. The computer scientists can care about that. So where do you go from here? These are just random games that you will find in your app store if you're using an iPhone. This one, a model about a restaurant, cafe. That one is a hospital model. And this is a pandemic model. And these are actually available in your handheld device. So we are not really far when we talk about the simulation software being primitive and we're not able to do this or that, and we have to have all these licenses. There are things there already. We have reached that place, although they may not be able to do exactly what we think of like a simulation package. But if we can do this, that means around the corner, we can actually develop a handheld simulation that for a doctor can come and just run a very quick simulation about their patients and then let the next phase go. So, and you can bring them together. I will now let Nav talk.
Good afternoon to you all. So I will just begin by saying, a few personal memories of Professor Ray Paul. So this takes me back to year 2004. And I studied from Brunel University, which is now called Brunel University, London. And I'm honored that I'm sharing the panel with my first supervisor, Professor Simon Taylor. And Professor Ray Paul was my second supervisor. So I just completed a master's, and I may be able to connect with some of our early career researchers, prospective PhD students looking for scholarships. Okay, you feel that, right? Okay, you have a good mark, you have a distinction, have a paper, and then you want to do a PhD, and then you think that you hang in the department for some time, right? You attend the seminars and all, then maybe there are opportunities for you to get a scholarship, right? For you to, study. But as we know, life maybe does not turn, the way we would want to. And that is where I first remember, because I had conversations with Simon, and he said, why don't you go and just have an informal meeting with Professor Ray Paul? And maybe we had a few meetings, and it was less about research. I don't think in terms of supervision of the research, material. I mean, the PhD itself, Professor Ray Paul had a big contribution, but what you learn in life, right? And just by looking at example, I think that meant a lot. So just going back then, so after the few meetings, so one day I hear that, okay, Nav, you're not going to get a scholarship, but you need to work for the department as a RAE assistant. Now, what is RAE? Some of my distinguished colleagues will know. RAE used to be what we know as the REF now, Research Excellence Framework that we know now. It used to be called Research Assessment Exercise, 2008, right? So, and okay, now it has become a very pressured kind of thing. You all know how it is, but that time it was more relaxed. But we still have to, collect a lot of data. And at that time, I was just kind of, in exchange of my PhD, the tuition fees and things. So I used to work as a RAE assistant, and that kind of meant that, I could then continue my PhD and, then get an academic job. So that is my, obviously I have many other things to share. But in terms of the career, I owe a lot, and also learning from him and through example, right? So the papers that I'm going to talk to you about, I mean, these both the work, this is on SSM, Checkland work, but the idea was at that time, just look at the year of publication, 1994 and 1996. It is how do you combine soft-to-hard technique, SSM, for messy problem situation? How do you use it in order to, have a participatory approach, a facilitated approach, whereby you go to the stakeholders and you involve them in the process of modeling itself, and thereby how do the stakeholders of the models then gain trust? If they are involved with it, then they will gain trust. So now, currently there is a lot of literature, a lot of researchers working in the use of SSM in different stages of the model, building a discrete event model. And I think I remember in OR 64, I think it was in Warwick, now use of SSM and partisim approach. Some of you would know Kathy, if she's here, Antuela, they have kind of pioneered in a way, and that has taken off, and it is a framework in itself. But we could perhaps trace back that work to these early papers. And so another thing, interesting thing, which I find, that the use of SSM in healthcare operations management. So these are all, this is a part of a literature review, right? And so this is the use of SSM in healthcare operations management, not all of them simulation. But you will see at the top is the Lehani and Paul paper of 1994, which then starts the process of how we use soft systems methodology and discrete event simulation at that time. Okay, there have been previous work on hard and soft, you can say, mixed method, but use of SSM with discrete event simulation for the formulation of the conceptual model, and the approach that it takes you through the 7-step approach. We find it in this paper, and this was applied to a case study at the Watford Hospital. You could see that from the name of the paper. So now it was interesting then to see when this is 2014, and one question which was asked by Tilal was, where we are now, in terms of this use of these approaches. And I thought that one way to really show this would be to do what you call as a co-citation analysis, right? So what it is, so you have these two papers, right, which the number of over 100 citations, and you see who cite them, which authors have cited those two papers, right? So you have a collection of 64 or 65 papers, and you take those papers, and these 64 papers have cited other authors as well. And you try to build the knowledge using this different, network connections, where, if authors are using certain body of literature, together, it means that it has got a stronger coherence, and then that is the, shows a bit about the knowledge domain. So this one is not a co-citation network, but based on the similar thing, but it is using authors' keywords. And what you could see, and all the papers which are included here is from after 1994, and you could see the use of SSM and simulation, right? Because we are only using those authors who are referring to those two papers. And you could see soft, which is software simulation, discrete event simulation, conceptual modeling, and these diamonds have got different colors, because what I did for this was I divided the data set into 3 sets, right? Just to see the evolution of the field. So you have 1991, which is the start year of the paper, to 2001, that is one time bucket. Then you have the second and the third. So what do we see from here? So for example, strategy development. So there have been some work in strategy development with SSM, but healthcare, but that has been mostly 1994 to 2003. Simulation, use of simulation with SSM, it has been, there has been some work in the first time bucket. Majority of the work is 2001 to 11, and even now it is continuing. And soft systems methodology, obviously, because it was one of the defining the keywords, is the most prominent here. But we wanted to look a bit further and see how the existing researchers are then using SSM and different types of simulation, and how the knowledge is getting, you could visualize, right, using co-citation network. So you'd see a lot of people that you may recognize from here. And we can again look at the time buckets, and you can see their Kotiades, Robinson, Taco. So that is the work which we are talking in terms of the partisim, most probably. It is, I think, and Sally, Tilal as well. So these are all work which is related in a type coupling. And then we see another kind of cluster emerging, and which is the more recent cluster. You can see it from the color. So I did some cluster analysis on it, right? And so this is all automated, right? So if you're using a bibliometric software, you could use, how do you cluster the items, the articles? Is it by the title, author keywords, or the abstract? And you can use an algorithm for that. So what we see here again is, how the since the publication of the papers, how it has evolved, right? Use of SSM simulation, and you could see again a very prominent cluster, facilitated modeling, right? It is number one. Then I like healthcare again, very, very important in the clusters, and again, you could see it in 2 different time buckets. Another thing that we see is that hybrid systems, right, is emerging as a cluster of its own, pretty recent, cluster, but this is not hybrid simulation, but a hybrid, model, hybrid systems model. So here again, what we are talking about is the use of, soft approaches together with, a more quantitative computer simulation approach. So there is a cluster there which is forming. So I think it is a good way to see that from 1991 onwards, how this particular area of using soft methods with, computer simulation has progressed over time. So the last part I was told was to discuss some ideas for the future, and I'm just going to talk about use of soft OR and with hybrid models, and so I think there is more work that could be done. SSM is but one approach which has been used for the to help in the conceptualization of the model, and obviously you do it together with the stakeholders, which then actually helps you build trust in the model, right? Another study that we have done, it's called the facets of simulation, the facets of trust in a simulation study. So we have seen that the different facets that may exist between the model and the modeler itself, the trust the modeler feels for the model, the trust that the stakeholder feels for the model, and the stakeholder trust for the modeler. So these are the three facets. And obviously, soft OR, participative approaches, issue mapping, group model building. There was a question today in the first, the first session, that why can't we use Delphi method, right, in order to capture some of the requirements of a modeling study, right? Delphi is also a qualitative, method, right, forecasting method. But is it possible that during the conceptualization of the study, we may be able to take some more? SSM has been used a lot, but there are other approaches as well. So when we think in terms of soft OR and the fact that we would want that the results of our model is implemented in reality, and which means that the question of trust becomes very important, then I'm thinking about the more inductive learning models now, the machine learning models, which is just learning from data, right? Now, how would you, go about to the stakeholders and say that please accept what it is giving is right? Okay, we don't want to be like we had the financial crisis of 2008, where the big bankers say in the Congress that the models had become so complicated that we don't know how it was calculating the credit default swaps, and they say that in front of the Congress, right, in the hearing, right? So when you are doing the inductive models, and a lot of these models now that we are using, simulation models is having some machine learning component in it, and how are you going to make the stakeholder accept it, right? So what methods could be there? And I'm not saying that it is a soft OR approach. There could be something else. So the trust in model is very important, and then there are obviously initiatives like explainable AI, ethics in AI, diversity modeling. And I'm not an expert in AI, but these terms appeal to me. They speak to me, right? So okay. So so I need to finish, but it's been an honor being invited to the panel, and thank you all.
Yeah.
Great. Thank you, Tilal. And yes, I'm going to be talking about ClinSim, actually, which Stuart mentioned in passing, but the papers I referred to are actually a bit earlier. And in fact, this model actually started in the 1980s, and it was quite interesting to read about how it began. The ideas in it are incredibly modern and up to date. We're all talking about generic reusable models, and also models that can be used by NHS staff who are not necessarily simulation experts. So all of the things that we have around that we have today, and that the so-called user-friendly things, these were the principles of ClinSim. So the idea that it used sort of pictures and graphics in order to engage the stakeholders and to help them understand how the system worked. And I think, the key thing again that Stuart mentioned was the idea that the purpose of the model was not so much to come up with an answer, but to stimulate debate and discussion, to act as an interface between the different stakeholders, to let them essentially work out the answers to the problems themselves. And so it was actually taken up and used by the UK Department of Health, as it was then called, back in the early 1990s. So it was incredibly ahead of its time. But I think one of the things about working in health OR is that you realise that we're still working on the same problems that they were working on in the 1950s when OR was in its infancy. And one of them was about outpatient clinic performance, the fact that there were really long queues and clinics that were supposed to finish in 3 hours were taking 5 hours or something. But essentially, it seemed a fairly simple problem. It's basically just a relatively simple queuing network. I mean, not even anything as complicated as an emergency department, just you check in, you might have some tests, you see the doctor, you go. So it was going to be an MSc student project. Initially, you had to do this in 3 months. But what the student discovered was the term that Ray used was an iceberg problem. In other words, that the sort of tip of the problem was the bit that you could see, but when you started investigating it, you realized it was actually enormously complicated. So that was actually in the late 80s, I think. And then this model was handed over to a small software company who actually tried to code it in Pascal. But they also found that actually the problem, once you started actually digging and actually trying to scope it out, it was really too complicated. So actually nothing came of it. So it wasn't really until the early 90s that Ray and his team actually built Simulate. So as Stuart said, it was built in SimScript, and something called Auto Menu, which produced it produced output in the form of Word documents. So you ran the model. So it kind of links in with the sort of thing that Tom was talking, and an incredibly early precursor of it. Where it actually produced output and reports and graphs and things that you could just put into a report and give it to the hotel manager. And so it was taken up and used by the NHS. So this is what it looked like. Of course, when it ran, you saw the animation and the patients moving around and so on. But it was really quite a simple system. You had test rooms, you had a waiting area, you had doctors, and you could specify within certain limits how many of each you had. So the idea was that that as a user, you would say how many doctors you had and how many rooms you had, and then what your arrival rate was. So you can see why they thought that was a student project. But of course, the complexity arose from this sentence, which really made me laugh when I read the paper. So this is from a WinterSim paper that Ray and his wife Yasna wrote back in 1975. And I think those of us who work in the NHS kind of recognise this, but it's when you actually start trying to understand, how do you model that? How do you actually say, okay, some patients arrive before the clinic starts, some doctors arrive before the clinic starts, they might see patients, they might not. And then some, there may be a queue of patients waiting to be seen at the end of the official clinic time. So you may shut the doors so that you don't let anybody else in if it's a drop-in clinic, but you're still going to see all the patients that are there. So it was trying to model things like that and to allow for all these possible complexity and put that into a generic model that could be configured by the user to fit a particular clinic. This is where all the complexity came. So one of the success stories that was quoted was at Leeds General Infirmary, where they had this really badly performing clinic that was always overrunning. So what they did was play around with ClinSim and using different configurations of operating practices and routing patients and things, and found that actually they could drastically improve their performance without using any extra staff, just changing the processes around. But as we said, it wasn't so much that there was some sort of magic answer to doing this. It was the fact that doing the experimentation with ClinSim enabled all the stakeholders to actually work out the problem for themselves. So I think my final words about Ray, he was a very inspirational person. I mean, I never directly worked with him, but I totally echo what Stuart said about him being very difficult to say no to. So he was the inspiration behind the journal Health Systems, and he persuaded Paul Harper and myself to become two of the founding co-editors. I mean, it was an interesting journal. It spanned the information systems and OR communities. So we had 4 co-editors in chief, 2 IS people and 2 OR people. And Kathy is Kathy still here? She took over from me as a very suitable person to take over from that systems perspective. But the idea of behind Health Systems was that it spanned these communities, and systems broadly understood. So systems meaning IT systems, and systems as in systems thinking as well. And of course, I don't know how many people have read his book about living with Parkinson's disease. It's a fantastic read, and it's very Ray. It's very funny, and it'll make you cry as well. But it's very inspirational. He also wrote a paper. That's probably like a poem from the patient's perspective, which appeared in the first issue of Health Systems, about experiencing the NHS from the patient's perspective, obviously relating to his own experience, but seeing it through the eyes of a patient who has also spent a lifetime in modelling, which again, I've thoroughly, it's well worth reading. So, I mean, I just to say he influenced me enormously. I never worked directly with him, but I think his influence has permeated this workshop. So he was one of the people that prompted so many of the things, JOS, Health Systems, this workshop itself. And his ideas were definitely way ahead of his time. We're still struggling with some of the issues that he identified back in the 1980s. So thank you very much, Talal, for organising this. It was a
So it gets better. I know it's going to overrun, but it gets better. So I hope you're patient. Yeah.
People have shared reflections with Ray, and I have to say, I still find it a bit difficult to talk about somebody I knew quite closely for a long time. I'll just say it was great fun. So moving on, hopefully. Now, some of you might have heard of AI. I believe there's some discussion about simulation and AI going on pretty much all the time. Now, who are you? Back in 1985, Ray published a paper with Georgios Jakidis, who's now a professor at a university in Athens, very successful one as well. They published a paper on research into expert systems to aid simulation model formulation. Apparently that says image 1. What have you done to my slides? Where is he? Anyway, just ignore image 1. It's fascinating. So that was kind of like the last big iteration of AI before what we have now. Does anybody remember MySim? Okay, so many of the literature reviews I read from PhD students in the area don't remember MySim either, because it's kind of like prehistory. Some people talked about Python. Lisp as a proper programming language. Bracket, 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 if anybody's ever programmed in Lisp. Change my slides. The dead clever thing about this is basically Ray was always fascinated by new things. So when the web came along, he was really excited by that and about the possibility of the World Wide Web and simulation. Back in 2000, then very little happened afterwards for a long time. Now it's all about cloud, but I think he'd be very fascinated about what's happening now in AI, because at that time, Georgios and he spotted MySim and just asked a simple question: can we do that in simulation? Instead of prescribing that MySim did, what's the best, based on the symptoms that a patient has, what's the best drugs to give them, basically. They said, well, can we use a similar approach to build models? Now, okay, it was slightly easier because there's ACDs, activity cycle diagrams, which of course everybody is intimately familiar with. Probably not, but they were the first sort of modeling notation that we had in computer simulation that Tucker brought forward in 1961, I think it was, something like that. But it's great, nice, simple notation, some good syntax behind it. So it kind of lent itself towards a model generation. So they they created a program running in Lisp, running on an Apple II, which is even greater, you know, sort of really prehistory in terms of computing here. But they did something very clever as well. They made it a natural language processing system. So you could actually write in free text, a little bit of structure there, to actually create your activity cycle diagrams and run simulation. Now, these days, I'd love to share the DOI and the code and all that sort of thing. Those days, you didn't do anything like that, so I haven't got the code available to run and play with. But what a fantastic idea 40 years ago. You know, it's ridiculously ancient. So now, I do wonder what it'd make of simulation and artificial intelligence or machine learning, because there's lots of new toys, there's lots of exciting research themes. So just comparing the two, and I had more slides, but I thought I'll be the end, so I'll be pushing 3 o'clock, so I reduced it down to just a couple. But just this is fun. I've been doing this a lot recently with the AI group in our department. Ray recruited me to Brunel back in 1993, I think 91, I think it was, 91 or 93, I can't quite remember. He also recruits a lot of the people in the intelligent data analysis groups. We've known each other for a long time. And this is the thing, Ray spotted talent, recruited, and we're all kind of the same. It's the same in our department now. Everybody's dead nice. Everybody works together. Everybody gets excited about things. It's a lovely environment to work in. So we're getting excited about simulation and AI machine learning because it's quite complementary. So simulation, we can get away. Well, sorry, machine learning doesn't need a lot of domain knowledge. And that's one of the big problems with machine learning, because you don't really know what it's doing. So it's inferring from data. Whereas in simulation, we do a lot of domain knowledge, but because we do that, we understand the crane's not running as fast as it should be and solve the problem. Data, this is really exciting. We don't need a lot of data because we use distributions. Machine learning needs a lot of data to create distributions. You know, it's a funny relationship there. Computational speed can be slow. Well, not if you work with me, because we use lots of parallel computing to speed things up, which can be a little bit tricky, but it's good fun. Machine learning then cheats. Machine learning and AI is very quick, but nobody tells you the amount of time that you've been running programs to use training data to create the algorithm that is very quick. Anybody went to Ross Barton's tutorial on meta modeling? Is very similar. You spend a lot of time creating the meta model, a lot of time testing, and then the meta model is really quick. But have you done all the thinking already? Do you actually need the meta model? Explainability, well, simulations couldn't be easier to explain because you take the stakeholder with you on the journey. AI is kind of, well, there's the answer, 42. Really, what did that actually tell me? You know, extrapolation, interpolation. I was talking to, I don't know if Anna is here, but I was talking to her a couple of days ago about this. And she came up with the witty observation is that AI is brilliant at what was. Simulation is great at what if. AI is brilliant at explaining what happened. And assuming everything's the same, it can be used to tell you what's going to happen, but nothing's the same in my life day to day. So, but it could be useful. And then methodology, pick a simulation package or technique, use waterfall or rapid prototype and model development. There's nothing new there. It's all fairly standard, well understood. Machine learning and AI, it's a big secret here. And I've talked to people in government about that. You kind of pick a bunch of AI machine learning techniques, apply them to the data and pick the best one. It's not really great because people in government say, well, we can use machine learning to solve this problem, but there's about 400 or 500 different types of machine learning. Most papers published in the area compare them and just say, well, this one's marginally more successful, we can create a new one. I like simulation because our techniques are tried and tested. machine learning is still a bit of a wild west out there. However, there's some really good combinations though. There's really some great exciting opportunities for research. And I say all this is sort of borrowed and adapted from Jürgen Brank's presentation in a panel that I did a couple of years ago in 2021. I encourage you to read the paper because there's some really interesting discussions that cracked on there. And it certainly gave me a few ideas for some research that we're pursuing right now. But you can put AI in a simulation, you can put simulation in an AI, you can do simulation before AI, and you can do AI before simulation. But the point is, it's different combinations. They are complementary. Now, I just want to read something out just quickly. It's while simulations and AI are different concepts, they can be used in conjunction to create more advanced and sophisticated systems. Or that's what ChatGPT told me yesterday when I put simulation and AI into it. I could have written that well. But anyway, there's lots of good ideas. And I encourage anybody who has got access to an AI group to start talking to them about simulation, because they won't know about it. Journal of simulation, I think, how many papers we get in a year? About 400? Yeah. My colleague Zidong in our department is the editor-in-chief of neurocomputing. They get 8,000 a year. AI, the field is simply colossal. We're small in comparison. But in my recent experience, if we work with AI people, we present them with some exciting things. So that's what's happening in my department. We're coming up with new forms of many objective optimization, where there's sort of 10 to 15 KPIs. That's interesting because it's basically modified genetic algorithms doing the search. We can put it on high performance computing, do lots of fascinating things there, but it still comes down to the problem of which of the many approaches to many objective optimization can you use. I want to work with Ford and tell them to use that one. So there's no sort of success indicator. So we're trying to figure out, how do you select the best one given the profile of the model or whatever? Because you can't just go to a company and say, well, you've got to use all these different types of optimization algorithm and then in retrospect pick the best one. Well, we're getting there. And then the metric for me is we introduced a track at the Winter Simulation Conference last year. It went from 0 to a full track, rather like hybrid did, which indicates for me there's a colossal amount of work going on. And it's a good place to begin if you want to start to get some ideas about simulation and AI. And as Ray used to say, what's the point of doing things if it's not fun? And this is. So thank you very much.
Right. So thank you. I will now just give chance for people to have any comments or any thoughts or feedback. I know it's the last session. I put this not just to show that we'll be sitting for discussion. Actually, everybody had a personal story with Ray, and everybody probably remember the first time they met Ray, like Simon, because we work in the same department. I have millions of stories, but I just brought this one. One day, Ray met my wife, and I said to her, thank you very much. Your husband was actually doing nothing for 2 years during his PhD until he got married to you. And we moved into a new house, and I said to him, I don't have any furniture. I didn't mean that to ask him. So he got me this as a present. So it's still with us. So many things changed over the last 22 years. This one is still with us, and we call it the Ray's Couch. So it's Ray's Couch, sorry. So he gets into you in different ways, and you cannot say no, like Sally said. So in this note, I'd like to thank you all for staying for the whole panel. And we will have a picture here with Ray's picture in the background. If you want, you are welcome to join. And the panel also agreed that we will work together in a special issue for just for the work of Ray. And thank you very much, and have a good journey home.